I'm Harry Forbes from ARC Advisor Group. Welcome to this session on business value through edge analytics. I'm going to have a few, what the format of this session is going to be is I'm going to have a few remarks at the beginning. Then we're going to hear from Schlumberger. Then we're going to hear from Lucky Peak Power, two kind of diverse applications. Then we're going to have a panel discussion with Q&A. So I just wanted to say something about this. I won't take very much of your time, but edge is kind of, in all the COVID stuff, despite all the disruptions and all the other things that changed in COVID period, edge computing kind of got, if you will, it got kind of sexy during this period. It got a lot of hype. So like everything that gets hype, there's a lot of hype. And so you hear these statistics like, well, in 10 years, 80% of the data will be processed at the edge, or it'll be 82% or something like that. But despite the hype, there really is something here, and I just want to talk about it for a minute. And especially when it comes to automation, what we've seen is the innovation cycles are ridiculously slow. So we were joking about this. This was the automation architecture in 1995, and then you go 25 years later and we've changed the color of the hose, but everything else is pretty much the same. Maybe we have we have newer versions of the Microsoft Windows operating system running on the panels and that kind of stuff. And we probably have cybersecurity applications and so forth. I'm being a little unfair, but really, we haven't seen the kind of revolutionary change in automation architectures that we've seen in IT architectures. And the innovation cycles tend to be very slow. Now, my personal opinion is this is going to change. That's probably a little bit a risky thing to say because they don't usually change, and here's why they don't. You have a real high cost for downtime and failures, and depending on what the industry is, it's always a high cost, but it can be millions of dollars per day or even millions of dollars per hour. Reluctant players, which means that both the end users and the suppliers like the situation to some degree where they have a walled garden and that the suppliers have a silo they can deal with, and the end users have one throat to choke. They have somebody they know they can deal with. And we have very long equipment life cycles. Someone was saying at one of the sessions this morning that the consumer electronics turnover, product turnover, is measured in months. The industrial product turnover, industrial automation product turnover is measured in years or even decades, so 10 years or more. Certifications are necessary but evil in the industrial space. They're absolutely necessary, but they definitely add to delay. And of course, the usual lack of global standards. So we have plenty of standards to choose from, but not very many global. And these are some comments that came out of our European research with end users. Some of my European colleagues talked to some people about the lack of innovation, and this is some of the things they said. We can't add complexity. We need a clear business case. We need measurable change. We have to buy proven technology, and we test and pilot things for years. And sometimes we just want to do everything ourselves. And of course, a lot of times in the manufacturing environment, what people are doing is, the cliche would be putting out fires. They're doing whatever it takes today to keep the production process running on spec and at volume as best they can. So it's not an environment many times that's really conducive to rapid innovation. But I'd like to share a couple of points that a presenter made at the forum I think it was the last in-person forum that we had at ARC, which I thought were very perceptive. This was a gentleman from a major automotive company, Audi. And he said, if I need a specific function today, then I buy an appliance or a device with that specific function. So you can think of these appliances as being I/O nests, PLCs, firewalls, whatever. But we're kind of in an appliance mode in the automation architecture. And what he was trying to drive his company toward was buying a standardized offering and adding functionality through software because he already had the infrastructure that he needed on which to execute. So in a way, we're seeing this come true. Not so much right now in the automation space purely, but we're seeing it come true in many ways in analytics and other kinds of applications where we have a more standardized, I wouldn't call it an appliance, a more standardized hardware-software platform at the edge, executing perhaps some automation application and perhaps some other kinds of analytic applications, and they may be the more valuable ones. The other thing this guy said, and he was looking forward to a virtualized and containerized software environment for his edge devices. And people said, well, why do you need that? Because they already had a lot of industrial PCs. And he gave a census of something like 45,000 edge points or industrial PCs that he had in his factories. And I don't remember the exact statistic, but he said something like a third of that number could not even be serviced remotely at all. So that they had 15,000 systems that they had to go service in person. And the number of people and the difficulty and the lack of the lack of ability to manage those systems remotely and to manage that number of systems remotely was an extreme pain point for him. He had a whole organization that was trying to, to update all that infrastructure, which was extreme pain point for him. And as he said at the bottom, it's an incredible amount of money we're spending doing this, and it's not going to go away. It's going to get more and more intensive, the kinds of upgrades and changes that they need. So he was looking forward to that kind of containerized environment in which he'll have not only a standardized platform, hardware, software platform at the edge, but will have the ability to manage it remotely and manage it at scale. So this, in my view, this was pretty much kind of the edge computing vision that he frankly admitted he was not close to yet, but I think is what people are hoping for, especially in industries, manufacturing, and in industries where there's distributed infrastructure. We have done some research in ARC on edge controllers, and we did a market study on this, and we found a bunch of products that are kind of like combining edge control and edge compute capability. And I'm not going to mention them all. You will be able to get these slides later, but two of those are represented here in the presentations that we're going to see. Phoenix Contact with PLC Next, which you may have heard about in the luncheon today or otherwise, and Zedata with a virtualized edge platform. But they do have company, and there are a lot of there's an increasing number of automation companies and other types of companies, software startups and so on, who are creating and partnering to deliver that kind of vision that the fellow from Audi was looking for. By the way, of course, we have a market study on this at ARC, so if anybody wants further data, I'm sure we'd be happy to sell you the market study. The other kind of thing we're seeing more at the edge is what we would call a classic IT hyperconverged infrastructure. So it's a small footprint appliance or system that incorporates compute, networking, and storage, and virtualization. If you look at some of the startups that we see at events like Hannover Messe and other automation events, we're finding this more and more that the applications, albeit proprietary, are being virtualized, and there's value in that. If you think back to the fellow from Audi who has the 15,000 systems that he can't service remotely, even if they're proprietary, even if they don't change, if he can virtualize that number of systems, then he's getting a lot of value because he has at least observability and perhaps serviceability of the applications remotely. The other part is you get help from the IT organization in managing the infrastructure, at least part of it, because it's not foreign to them. So to summarize, like, where is the end user value? Where is the end user value coming from this? And you can envision a system where the whole system is put together by different suppliers. And there were several examples of that on the showcase floor, if you did happen to look, where there was a mixture of suppliers that were automation suppliers and IT suppliers and software suppliers delivering a solution like this. Not highly standardized at this point, but we're moving in that direction. So the final thing I would say about the edge is that where it is actually located depends on who you are talking to, what industry you're talking in. So it's always good to ask for a context there, because if you're talking to somebody who's in telecommunications, he's talking about something entirely different than somebody who's in automotive or somebody who's in utilities. So there is very different amounts of compute and storage and infrastructure that they consider the edge. And in our case, in automation, it includes a lot of what you call restricted function devices that are really embedded systems with a specific function and not too much more than that.
Go through some details on the journey that we're going through still, like regarding deploying a little bit of intelligence to the edge in the oil and gas. So just for setting the context, so I work for Schlumberger, or I've been working for Schlumberger for the last 12 years. Schlumberger is an oil field company, which basically provides technology and services across the whole spectrum of the life cycle in oil and gas. So more specifically, I work on the SLIC, which is a technology center located in Sugar Land, Texas, which is in the Houston area, which stands for Schlumberger Industrial Internet Center. So we have our focus is in three different areas here. We focus on industrial IoT. For basically, it's like a central hub for Schlumberger as a whole for developing the infrastructure for the IoT solutions that we have. We have also some focus on automation, which is basically enabling the field equipment or digitally enabling them. And also another focus on digital avatars or digital twins, which is a very hot topic that has been covered here in this forum very nicely. So just to make some brief comparisons between the consumer IoT and the oil field IIoT, right? The industrial IoT. So when you look into the consumer IoT, basically the first thing that it comes to mind is your smartwatches or the many things that you have at home, like your smart fridges, smart lamps, smart TVs, smart whatever, right? And one thing about these devices is that they are basically born IoT enabled. They are born IoT connected, right? So, and we always assume using these devices that we always have good connectivity, right? And typically we're angry if you don't have connectivity for 30 seconds. So now when we turn to the oil field scenario, so this is not necessarily true, because one of the things is that our operations typically are running in remote locations, right, where connectivity is an issue, right? And the other thing is that our devices are not necessarily new, right? We have a whole fleet of equipment which is old, right? It is extremely valuable, but it's an old equipment. It's not IoT enabled, right? and it's not smart enough, but still we have to find a way to make these devices a little bit smarter, or the processes that use those devices or those equipments a little bit smarter, so that we can improve the efficiency and sustainability of our operations in general, right? And the other thing that is pushing, or it's a stronger push for IoT in the oil field is with COVID, just like any other business, right? So to enable the remote operations, right? And the other aspect that is very different is we're dealing with critical infrastructure with lots of safety concerns in running the job itself, right? So one factor which is has to be taken into account is very, very seriously is the robustness of the systems that we deploy there. So we're talking about the edge. So in this context, the edge is the well site, and the well site is not necessarily a nice environment. It's typically a harsh environment. So you have high temperature, you have high humidity, you have vibration, you have lots of dust, shock, etc. Right? So all these conditions combined create a very challenging environment for your hardware and software to operate properly. So one of the things that typically you have to do is ruggedize your equipment, right, to make it to work properly, right? And typically you have in this area here, you have two types of equipment. So you have what we call the surface equipment, which by definition it's on the surface. And you have the downhole equipment, which is the equipment that you put down the well, right? And then now you can imagine, right, you have this metallic cylinder, and then you put your electronic with your firmware there, and then you have temperatures above 100 C with humidity. Humidity becomes steam, and then you get the point, right? So the other thing that mentioning regarding the connectivity, right? We are typically in remote locations, like where the only resort sometimes is for communication. If any is using satellite, which is a bit flaky, so high latency, outages happen very often, right? So another aspect here is regarding data. Data is king, and there has been like a paradigm shift where we process this data. So in the beginning, you used to have everything being done at the edge of the well field with your local human expert with access with the data, and people distributed in different areas with all the silos. People don't talk to each other, right? And then it starts to have this movement. Okay, let's make our devices dumb and push everything to the cloud, right? And to solve this problem, right? But we have, as we're saying, so we have this problem with connectivity, right? So this is one thing. Problem with bandwidth, because satellite is expensive, and who said that your client is willing to push all its precious data to the cloud, right? So then what we've seen more in the last few years is more like a sort of not going back entirely to edge, but more like a hybrid model, right? So you keep everything that you have to keep close to where the action is happening, and send only the relevant thing to the cloud as needed. So taking all of that into account, so communication, I think that's already pretty clear, right? So again, typically when we are working with IoT in the oil fields, typically we say that sometimes we don't have the I in IoT, right? So you have to design your system to make sure that it works autonomously in case you're in an offline state. And also you have to think always in the bandwidth optimization because of the costs of satellite communication. Security, I think it's bottom line is security is important regardless of the IoT type, right? The difference here is that because of we're dealing with things that have a very high HSE risk potential. So an incident here or a security incident can have a catastrophic impact. So resilience. So we're running like mission critical operations that cannot fail. So you have to think that in ways to make sure that your operation will keep running as expected. We have all of these problems that we have to deal with, and at the same point, we have to make sure that we had the factor of extensibility. The meaning here is we have to simplify the life of the domain expert that are solving a domain problem, right? So that they can focus on their domain problem, and the rest is sort of abstracted to them, right? So that's the only way, and make sure that these different small solutions can operate with each other. Otherwise, it's very difficult to grow as a whole. Remote operations, more and more. I think this is something that has been repeated over and over here in this several days of this forum, right? So the things with the connected workers, right? And also here, we're dealing with a fleet of devices that we have to be able to manage at scale, right? And make sure that we provide the tooling and the smart alerting, or making sure that our operations team that is managing those devices, they are brought to attention to the specific devices that need attention. Last but not least, data residency. So in this case, public cloud, in-country, on-prem, you need all of this, right? Public cloud, not all customers are really open to use that, right? Some of them are, right? There is an advantage because you can leverage the native managed services that the cloud providers give you. Then you have the in-country, where sometimes you have government regulations. You have to ensure that everything is within the boundaries of a specific country or region. And then you have the case of on-prem, right, or the hard on-prem, as you call it, which in the case where the client basically everything keeps within their network perimeter. Yeah. So basically, this is sort of the things that we have to enable deploying things and operate the things that we deploy. At the middle of this, we have what we call our edge gateway, right? This edge gateway. And the left-hand side here, you see your devices that you're operating, right? And then typically you have some sort of controller in front of those devices. And then the gateway is communicating to those devices via like several different protocols like Modbus, OPC UA, and others, right? And from the gateway to the cloud, so the typical communication media, you have satellite and you have cellular as well that is supported. And one thing is that when we onboard devices to our cloud system, so we have to ensure that we have a strong identity. So on these devices, so leveraging things like a TPM, like a trust platform module, it's very important. So to ensure that we have a strong identity, we can ensure that the device that is connecting to your system is really the device, your device, right? And then on the right-hand side here, you have these three different areas, right? The concept of the marketplace. What happened here? What did I do? I don't know. All right. Okay. Let me go back here. Yeah. So the concept of the marketplace here, right? So where you have this suite of different solutions that you can pick and choose to solve a specific problem and deploy to your system, to your gateways, or to your fleet of gateways. For data control, like ingest the data from your devices at scale, and have the ability to control those devices, have visualization interfaces, so on and so forth, as well as device management support, right? This is really critical. Having a single pane of glass to provide to our operations team, so that they can manage their devices remotely and in an efficient manner. So when we look inside the typical edge gateway, right? So this is what we think. So we have typically you have your hardware layer, you have your industrial computer, and then you have your operating system, and then the idea is that you have your sort of plugins that you have on top of your of your operating system, right? But in order to have that in an efficient manner, so it's surprise, it's not we have containers, right? So it's today basically we no longer have a monolith, right? So we're trying to break things apart so that it becomes more manageable. But yeah, it's not only like, okay, I put in a container, I deploy, and then, okay, it's done, right? It's a little bit more complicated like that, because you want to make sure that whatever you deploy, you can operate with the other thing that you have deployed in your system in a more efficient manner, right? So you have to provide some sort of layer for with some core services, right? With message broking, like security monitoring, health monitoring metrics, right? Access to peripherals, means to access your gateway locally in an offline mode securely, like using like YubiKeys, ephemeral certificates, so on and so forth, doing like over-the-air updates of your operating system. And then you have to provide the basics, like as part of the platform, the basics of your southbound protocols, like your components that come out of the box that already talk the protocols of your devices that you're connecting to from the gateway, and bring that are acquiring this data and bringing this data into the system in a common data format, right? So the idea to normalize so that it's a bit easier to exchange information between these things, right? Data management, so things to get the data either from your southbound devices or from modules that are computing some sort of data, derived data, right? And bring into the same in a single place where you can manage this data. And cloud connectors, right? Something that can manage the connections, the secure connection between your gateway and your cloud provider or your remote server, and in which this cloud connector behaves as a cloud gateway, like acting as a proxy between what's happening on the gateway and also receiving commands from your remote server, from your cloud, right? And then you have your edge computing modules, which is the things that we try to isolate, things that the solutions or the specific solutions that are trying to resolve some specific problem, right? That we try to isolate from all of this, right? All of this is good. All of this works. The thing is that we have something called legacy applications. Legacy applications, and we have plenty of them. So, and you can just say, okay, just containerize, and then you're good to go. But it's not. It's easier said than done, right? So sometimes the application is huge, it's complex. Sometimes the developers that worked on that application are no longer in the company, right? So this application is in a sort of sustaining mode. Sometimes there's no business priority for that, right? There's always like lots of things that are happening that need to be prioritized. So but the point is that all of these things, they're still working and they generate revenue. So the thing is that legacy and the more modern things, they have to coexist. There is no option of that, alternative for that. So another type of requirement that we're seeing is to supporting like clustering and failover, either within the same gateway or between different gateways, right? So first thing that comes to mind, like isn't that cloud, right? So you think in Kubernetes, you think all the things that you have in your Kubernetes clusters in the cloud, and that's right. I think it's more and more like the infrastructure. You're needing like an infrastructure at the edge, which has some similarities in terms of features to what we have in the cloud, right? And also, again, device management. Now, device management for all this additional infrastructure, right, and securely and at scale, right? So, if you look, you try to update the last diagram. This is more the thing that you're looking at, so that you have to have. So, you have everything that we had in the previous slide, plus have your clusters, plus the support to have your VMs running with either Windows, Linux, or whatever you need, right? Which means that pretty much you need this hypervisor, this virtualization engine to support that. Now, just going through some, so all of this infrastructure that we have to build to support or to simplify, as I was saying earlier, right? To simplify, simplify of the domain expert to solve some specific problem and focus only on that particular problem. So there's this use case here, like with video analytics, right? So again, we're talking about this old equipment, this aging assets that we have to maximize their use, right? So there is this specific case here where there's an offshore rig, right, in a remote location. So you have these gauges, and these gauges, they are not connected through a DCS. So, and from time to time, what happens is that operator needs to send the technicians to this remote location to this to basically do the manual data acquisition, right? So the guy is going to read the gauges, annotate, and then take it back, right? So we have a few problems here, right? So first, you're increasing the agency exposure of the particular person, right? And it is an extremely inefficient surveillance mode, right? And you're lacking opportunities to troubleshooting and to optimize your system. And then solution here is, it's not as easy as we might think, like, okay, let's just replace and put modern gauges and it's done, right? So it's you have a limited CapEx budget, and you have to maximize the use of those devices. You have to recertify all the things. So what can we do? So we can deploy a gateway to that location, and we can connect a camera to it, right? And then you work on that model. You put that camera facing the gauges, and then you work on a model that is going to read all those gauges and is going to digitize the readings, and is going to digitize and then stream this data to the cloud, right? You train this, and then you containerize your model, and then you deploy as an edge computing module, right? So immediately you're already solving certain problems, right? So you have a more real-time monitoring of your system. You don't have to make your personnel to travel to this remote location, right? So, and you can enable things like having like a dashboard to monitor all of this. You have APIs that you can make available for other cloud applications to leverage this data that is now being ingested. There's lots of benefits that I already mentioned. I'm not going through these numbers, but you can see that basically, so you can see that for this particular study, you have a huge reduction on the manual effort and the agency exposure, right? And at the same time, there was a benefit and increase on the optimization of the system. This is a simple example, but you see that with a little bit of creativity, you can still work around your limitations and still provide some value for someone, right? In our business. Other use cases. So there are multiple, like for example, in a facility, monitoring, like using video analytics for agency surveillance, like. So you have to comply with using like PPE, right? So you can use that basically to track if people is using like hard hat, gloves, boots, and so on, right? And then monitor that and see if people has been compliant, and then this is good information for management to take some action, right? And also other things is like red zone detection, right? So sometimes you're not supposed to operate an equipment. If a person is located in a specific area, you can have mapped that specific location and then alert if someone is going there and avoid that someone gets hurt, right? More recently, like today we don't have those restrictions anymore, but things like enforcing COVID-19 guidelines, like use of masks, social distancing, this is something as well that you can keep track of. Another case is flare stack. Flare stack this is a typical image that you associate with the oil and gas business. It's not only the oil and gas business, but there are other industries as well, But basically, this is you have this tall pole-like structure, right? Where you have like flames coming out of it. So this is pretty much like a gas combustion device, and the purpose of this is there are multiple purposes. Like you have to one of them is to manage the gas waste, right? Gas that can be processed, or it can be used for stabilize well pressure and flow, or for in case of an emergency to release pressure, right? And one problem here is that most of the gas here is methane. Methane, CO2 is bad for the environment. Methane is worse when it comes to contributions to global warming, right? So the idea is that you have to optimize so that you burn this methane before it gets to the atmosphere, right? So here's basically the problem or the challenge is methane it's invisible to the naked eye, right? And we have too many flare stacks to monitor, so you have the typical problem of efficiency, right? So if you have this solution that you can you're monitoring the video streams, and this can work in different conditions, day, night, smoky, clear sky or cloudy. And you're going to have an alert much earlier, right? And this is going to ensure that you can optimize this device for maximizing the efficiency, right? Another use case here is methane leak detection in tanks and pipelines. So this one is it's as I mentioned. So methane is invisible to the naked eye. So, and one thing that might cause these leaks is like this old equipment. So you can have like a corrosion, mechanical failure, etc. Right? And it's good that you can monitor your critical infrastructure from a distance, right? So leveraging like things like optical gas imaging technologies, you can install things on your facility, monitoring your critical assets and provide immediate value, right? So continuous monitoring regarding these particular problems. Another uses for regular inspections is having like a portable sniffer that communicates with your gateway and then that informs or ingests data immediately into the system. Another different use case here. So one of the things, or one of the common problems that we see in the SCADA systems is that typically the optimization of those systems doesn't take into account the historical data. And in some cases in some locations, you have too many wells for a single person to monitor or take care of. And then what happens is that there's a specific case where liquid loading events were happening. So when this happens, so someone has to travel to the location again. So exposure, HSE exposure. It's NPT, non-productive time. So when someone is intervening to resolve this problem, the production needs to stop, right? So you can put a gateway there, develop an application, an algorithm based on the physics to monitor that more frequently, taking care the data that you're aggregating in the cloud to optimize your model, deploying back this into your gateways, and then you can actually make this algorithm take care of controlling the choke set points, so without any intervention. So for this particular study, there was it's being reported is it's a huge. I think the biggest impact is a reduction in the manual intervention. So someone that didn't have to travel to the location, right? So that's a huge benefit, as well as an increase in production. So these are just some examples that with despite having these equipments that are not necessarily new, right? So they're always, but we still have ways to optimize them or make them a little bit smarter, right? And improving our operations, right? So also just to some concluding things here. So IoT applied to oil field present its unique challenges, just like in any other industry, right? So our edge gateway has evolved significantly, and the way we deploy applications changed, and it's still changing, right? So one thing is that we came to realize that there is a modern applications, greenfield applications, they have to coexist, and they have to coexist for a long time with the legacy applications. So virtualization, it's a capability that we consider as key for our future here. So and remote operations, right? So all the device management. This is not a small thing. So ability to do most of your work remotely at scale and safely and securely, right? Giving the right permissions only for those who have a reason to perform certain operations, right? This is a necessary thing, and it's not it's a huge amount of work to get there. And there are many other cases that countless opportunities to improve the operations that of our oil field with this approach. So it's I think this is just the beginning of this journey. So and I think that's pretty much what I had to talk about today. So thank you.
Hello, I'm Derek Stone. I'm with Lucky Peak Power Plant. We are a small power plant located in Boise, Idaho, or just 10 miles out of Boise, Idaho. We started our integration project about a little over 2 years ago. So some of the topics I'm going to cover are who we are. I'm going to talk about our top-down, bottom-up approach to integration. I'm also going to cover how we laid down the groundwork for integrating into kind of a legacy plant, an old plant that was finished in '88 and hasn't had a whole lot of improvements done to it since then. I'm also going to talk about what steps we went through to integrate, show you some of the concepts we came up with to improve getting to those end devices and applying them to be able to do better operations. One of the big things about our project was that our alarming was terrible. So we had a ton of truncated alarms. And so that was a big part of our project, to be able to go in and talk to those end devices and separate them instead of them all being together. And then the other thing is, by having those end devices and having that real-time value, how do we display that data to the people that need it, the end users? And then lastly, I'll talk about, even though we're still in the middle, or I shouldn't even say the middle, we're still at the very beginning of our project, or our integration process. What are the hurdles that we're looking at getting to and overcoming as we move forward? So, like I said, we're a hydroelectric power plant. We are owned by the Boise CUNA Irrigation District. Our main role as far as a hydro plant is to maintain the flow of the river. Most power plants that they ramp up and they provide peak power to the end users. Our main objective is to maintain river flow. If they say this is the amount of flow that you're going to put down the river, that's what we generate with. There are certain situations where because a lot of our resources is in the mountains. If we are lucky enough to get an abundant amount of snow, then we might also do flood control. And that was one of the main reasons why the dam was actually put in before the power plant, was for flood control. So we also help out with that. Our plant consists of 3 generators. Total, we produce about 101 megawatts if we're allowed to put that much water down the river. The unique thing about Lucky Peak and in an integration process, when you think about who your stakeholders are, is we're actually managed and operated by Seattle City Light. So when you're talking about, like, all right, who do you got to get the answers from to go ahead and move forward, we have two stakeholders that we got to be able to appease. And so before I start talking about the top-down part of this integration process, I probably need to give you a little context of how this kind of actually started. So I've only been at the power plant for about almost close to 6 years, 5.5 years. We had an event happen where there was a situation on the transmission line. It opened up the breakers in outside. And so basically, just like everything's supposed to happen, breakers are supposed to open for the transformers, things are supposed to start shutting down. But as it did that, we started noticing that there were some cascading or dominoing effects that because we don't have any visibility in the end devices, we couldn't really give the answers to. We don't know why it happened. Was it operator? Was it an end device? Was it a piece of equipment? And so at that time, our generation supervisor, who was almost there, almost the extent of the birth of the plant from '88 on, I had a conversation with him about, trying to figure out why, and or how can we find out what causes? How can we go and solve that solution, take care of that problem? And what I told him is if we had some visibility of that stuff, that we could probably have a better idea what's going on. And so that kind of is what kickstarted us to start looking into integrating the plant. And so it's a unique dynamic of having someone who's been there a while, that knows a lot of the history of the plant, but also holds a lot of that tribal knowledge that isn't really passed down below. So part of getting that project approved, when you look from I was thinking, okay, we were going to do this integration project. From the top down, I'm going to get some of these things that are going to be really key to my success for the project. And some of those, you'd think that I'd get some standards from the top that they'd already know, like what kind of things we want to do to create a standard for integration. And also, project management accountability. Being involved in a 10-year plan that the integration process would happen within. And then if they're approving it from the top, you automatically think that everybody's on board. Right. So, sorry, that was a joke. So one of the things I noticed from the top, and a lot of people that have been there a while, the reason why it's legacy equipment is because there's not a lot of subject matter experts involved there. So, that was like one of the things that I noticed after already getting the project approved. How do I deal with that? And in turn with that, it entailed a lot of scope creep as far as my project goes. Everybody's like, oh, he's got a project. Hey, do this. It's like, whoa, whoa, whoa. That's not part of it. That's something completely different. And along with that, we had a lot of missed opportunities to integrate, which in turn led to a lot of pushback for the project. So having that integration. So as I saw that there, how do I get help from the top? I was like, all right, so maybe I got to do this from the bottom. So I thought, okay, well, it's been approved. I should have that support from the stakeholders, right? I should have buy-in from the field. I mean, I work with these guys. Everybody else sees the same problems I do. We talk about it all the time. We are the end users. How do we make that happen? Part of the things that was actually a good part is that we did have project requirements. Some of those are that the operators were going to be the designers. They're going to give the input for what we want to see from an end device, and as well as that we're going to do high performance HMI. And then lastly, the guarantee that we have subject matter experts involved with the design process and getting to those end devices. So as I was thinking about this and I started working towards those goals, I noticed that there was conflicting levels of support, both the top and the bottom end. So it's like, oh man, how am I going to accomplish any kind of success? So along with that, it was really easy to lose sight, for everybody to lose sight exactly what our requirements were for doing this project. Like, why are we doing this? Well, we had an event. We can't explain it. What are the requirements that you were going to do? Oh, well, we're going to have the end users do this, right? They're going to tell us what how to build this, how to make it effective, and push that forward. So shortly after I had the project approved, and we already knew this, that the existing generation supervisor ended up retiring. So in one aspect, it was hard to lose that kind of tribal knowledge. On the other hand, the person that filled the shoes had a lot more experience with seeing real-time data from a utility generating plant. And so what we decided to do after having a few conversations about how we're going to continue to integrate is that we decided that we actually need to come together. So we developed a plan to be able to tie the subject matter expert into our 10-year plan. We're integrating those processes and our procedures for the operators to be able to follow. And at some point, we'll hopefully get to that 100% people on board. If we have that, then it makes it easier to know if you're getting the success, and if you're not getting the success, what you got to do to get there. And still maintaining those requirements. I think one of the best things about the approval of the project was that the operators are going to be the ones that are going to be part of that design process. So as you know, utility has a lot of requirements. So that made it very difficult at the very get-go. And so one of the things we decided right out of the gate is like, look, let's just create an isolated network. We don't have to worry about anybody getting in. And what we're going to do is we're going to design it in a way that we'll have visibility all throughout the inside of the plant. So nobody can get into it from the outside. And so that's the steps that we took. We needed to make sure that it was going to be accessible, especially for all the end devices that we have throughout the plant that we wanted to upgrade and bring to the operator desk. The other thing, if you think about legacy, is about how old it is. So when you go into some of these plants that have had high turnover for 30 years, if you see the picture on the left, you run into things like that. And you're like, and when you look at it, you're like, oh, we're not going to fit anything into there. So part of the task before we even started getting to the end devices is we knew we needed to do some housekeeping. And so pretty much everything on the left fit into one terminal strip at the very top of the screen on the right. And so that allowed room for all the relays, all the I/O, and a couple other things that it did for us. By going through those circuits, we were able to relabel, redocument, and part of that process, it cleaned up a lot of things for us. We found that we had some documentation. Our prints weren't quite updated from other red lines from previous people. And so we were able to go ahead before we actually started to integrate to say, all right, turn everything back on, failure. That we actually were able to take care of those issues before we even started that process. So when we look at the integration process of what we have basically, I look at it as we have 5 assets. We have three generators, we have our transformers, and we have our station service, which is our 125 volt DC. So basically, when we have an issue of one of those, they'll basically send a signal to a light box that says, hey, this is the problem, here's your problem. And basically our PLCs, all it does is do flow control. It tells the units, hey, a little bit more flow, a little less flow. And along with that, we do have relay protection through our RTAC, which basically protects all 3 units. And because we're legacy, part of that process is when we have something happen with the light box or we have a problem with megawatts, we have an operator come out. He figures out the coordinates on the light box. He writes down that number even though it says what it's supposed to be. Goes to a book, thumbs through the book, A7, sink my battleship. And then you figure out what 20 devices it might be. So then you have to go downstairs and try to troubleshoot that. So the process that we're getting to is that we want to be able to connect to all our end devices. So we established our network ring, and we wanted a central location that we can bring everything to that we can then direct it straight to our operator desk. So that way the operator has complete visibility of everything going on in the plant. He doesn't have to worry about traveling through the plant to go look and see what a device says manually because everything is literally analog. And so that's the goal. That's where we're trying to get to. So one of the hardest things was to figure out what SCADA system we wanted to use to be able to pull all those devices into. And so we wanted to stay open. We have a lot of legacy equipment. We didn't want to be locked down to just one vendor. We just had too many things in play that it didn't allow us to do that. And so we ended up, we needed to find something that would allow us to prioritize our data and be able to deal with our alarming so we won't have the alarm drowning. Some of you might know the terms of alarm drowning or flooding or maybe fatigue. So most people, I think PC is the PC word for alarm drowning is fatigue, right? But in hydro, we use flooding and drowning, so because we have the water. So the other thing we wanted to do is we wanted to build the trends for a purpose, not for practice. We do enough practice of that when we do our time-based management, where we take our clipboard, we walk around and write the data down, and then we throw it on the shelf and we wait until 4 o'clock again to do it again. And we also wanted to make the data accessible. And so in this picture here, it kind of gives you an idea of like where we are right now in our control room. So we have 4 monitors that basically are for the operator to see all the devices that we have currently. If you look directly above the 4 monitors, you can see the light box. And it's basically nothing's lit, it's not telling you anything. It's just telling you that there's nothing abnormal right now. The big monitor that you see in the upper left-hand corner is our new annunciator monitor, which is a 55-inch touchscreen that we did, which not only just supplies the alarming capabilities for just that unit, but it also, instead of just being something that's just blank and doesn't give you any information, we're also using it to be kind of like at a glance visualization of what's going on that unit. And so we wrote a program for it to start cycling screens as there's no activity for that monitor. And so that way, when the operators are going in and out of the control room, as they walk through, they can see what's going on. They can continue on with their business if they don't see anything that's happening. And so that allowed a lot of freedom for the operators to continue on with the other things that they were responsible for without having to be locked down to a chair all the time. So back to alarming real quick, because it's a passion of mine. This is kind of an example of some of the things that we were dealing with. So as you can see in the middle, we have a turbine bearing oil temperature level. Sure, okay. So I'm not sure what I'm supposed to go look at with that. Levels or temperatures? And along with our excitation abnormal, or we call it abnormal, we had 20 different alarms that would come in, or could come in, and they would just bring that one light box to light up and tell you have an issue. And that makes it really hard to go down and troubleshoot. Like, where do I go and look for that? Is it all on the same level? Is it in the same piece of equipment? Even our documentation in our books didn't tell us that. And so there was a lot of time spent trying to figure out what is the actual problem and how do we fix it. So one of the other things that we did with alarming is we wanted to, as you can see here on the far right, I started creating alarm templates. So the idea that we came up with is that we're going to kind of apply ASA 95 kind of unified namespace hierarchy of how we were going to deal with our stuff. So we have our assets, we have our systems, and then we have our devices. And so as we look at the templates for our devices, we are separating them under our systems, and we bring a template up for that system. And as an alarm comes in, the actual device will light up red, letting the operator know exactly what device under that system is actually active. And we also are providing the tree of kind of like an electrical schematic of all the devices that are below that before it gets to its end device of maybe possibly shutting down. And so there's a couple of reasons why we wanted to do that. Sometimes there's a little bit of logic involved with some of those end devices. And so not only can you see that the device came in, but you can see where in that logic that circuit is. Is it a timer? Are we like 5 minutes out before we shut down? Is it possible to stop that? Can we go fix something real quick? And also, if you have something come up and you know it's supposed to go straight to a shutdown and it's not lighting up and it's not shutting down, you know that you have a fault in your system. So having that complete visibility over the entire circuit was important for us. So when we talk about trending, there's 2 points of view to look at trending. There's either you're going to do time-based management or you're going to do value-based management. And so we do a lot of time-based management with just the clipboards walking around, collecting data, and then we put it on a clipboard and we kind of forget about it. The whole idea is that we wanted to do with our value-based data is that we wanted to make sure that it's providing the visibility that we need when nobody's writing anything down. And I put this image up of a situation we had when we were doing some changes in our generation. And what we have is, at the top we have our temperatures, at the bottom we have the cooling water for our temperatures, and in the middle we have our generation. And so we noticed that when we change in our generation, because of the physics through the the penstock and our cooling system, it changed the cooling water when we made that change, which we never would have saw because we only go at 4 o'clock to write this number down. But until we started getting that real-time data, we started noticing that, hey, we're affecting some of our systems regardless if we know it or not. And so that became very important for our operators to start thinking about, like, hey, I got to kind of change how I work. The other thing we wanted to do from a high performance standpoint is be able to create that visibility at a glance. And so by creating some custom templates, we were able to make it so that as we were showing just temperatures, that they're unique in the aspect that the operators can just look over them real quick, say, hey, I'm in the parameters that I need to be, I can move on. I can go to the next set of temperatures. I can see that they're all where they need to be, I can move on, I can go to the next set. Some of the things that we try to do with the HMI or in our SCADA system and the data that we're getting is, if you notice, I have the little eyes up there. And so those little eyes are just standing for information. So one of the things that our old system had is we had everything just piled on one screen. And there was so much stuff on one screen, you couldn't tell what it was. And it's because everybody thought that you need to have all that data right in front of you all at one time. And so what we're doing is trying to just give just the data that the operator needs to know that he's at a normal situation. And as we have an event, or if we need to know more information, you can hover over the eye and it can bring up all sorts of information. It could tell you your set points, it could tell you the prints that it's located on, it can tell you the floor that it's at, or the other devices that are associated with that system. And so by providing the eye, we're trying to limit the stuff that you see at one moment, but have it available at your mouse tip, so to speak. So as we also talk about our visualization, this is our lower guide bearing. And as you can see, this is a picture of our lower guide bearing. So given the graphics of, like, how do you let the operator know what's going on the inside when you can't really see stuff? Not only just applying just the actual real-time value, but giving them an idea of how it's actually working inside. And then also, as you see, we have an eye down there, so we have extra information for the operator if he needs it. So as this works, the operator can look at these things and see that things are running normal. He could see just even by walking, it's very familiar to him about what he's looking at. One of the other projects that we just got done doing that was a little different than our Annunciation was we did a head cover project. And as you can see, this is what the head cover looks like. And if you want to get into it, you're going to probably need about 6 10-ton chain falls to pull that cover off. And so it's really hard for the operators to go in there and look. So by giving a graphic of how it actually works internally and incorporating all the relevant information on one screen that they need just to know that it's running at an optimal condition. And here we have a few more eyes. So like the eyes would tell you exactly how the PLC is working. It would tell you how that the VFD is working if it's running like it's supposed to. It would have that extra information that you might want to look at occasionally, but not necessarily need to in a normal situation. So we're still, like I said, we're still early in our process of moving through the integration process. There's a couple things that, even though we're an islanded network within our facility, we still have hopes to take all those end devices and all that data that we're getting and apply that to our maintenance and also apply that further up the chain to the top. There's a few things that we're looking at, like MQTT. And especially OEE is another aspect of bringing some of that data to understanding how we could be better with our equipment. Thank you.
So these are our speakers who you already met, the panelists who you haven't met, and I'll let them introduce themselves. From your right to left is Ben Pryor from Phoenix Contact, which is the supplier partner of Lucky Peak Power. Tom Henwood from Kyndryl. Darren Kimura, who is the Chief Operating Officer of Zedata, which was Philippe's partner from Schlumberger. And Herman Obermeyer, who is I think, Vice President or but the division manager for Andritz for automation. So I'd like to get all of you involved. So maybe we'll start with Herman, if that's okay. I'd like to know, maybe you could explain to the audience, your view, a little bit about your business, and then what your perception and work on edge computing and industrial edge computing. And you'll have to share mics, folks, so you, okay.
Thank you. Yeah, Hermann Obermeier, responsible for digitalization in the Andritz Group. Andritz Group itself has roughly 20,700 employees and is a huge manufacturing for machinery and equipment. And we also have roughly 1,800 automation engineers in the group. And since 2007, we are developing software for automation and digitalization. And for the discussion today, I want to give you my input in terms of why did we develop an edge control ourselves. The story behind is very short. We have a lot of automation engineers and we have just a few data scientists. And it was always the same. We all know that AI is key for future functionality. There's no discussion about. And we always had the problem that we couldn't deliver in one project together the AI functionality and the control system. And for that, we developed the engineering tool chain to combine the programming of the automation part together with the AI part. And this is the reason why I want to hear what is your opinion about that. Is this a problem that also is in the field, or is this just a problem what we had, that there are so many functionalities in the AI engine which cannot be used because of the lack of the engineers which can deliver this?
Okay, thank you, Herman. I'll move to Darren now, if that's okay. Darren, would you introduce yourself? And I think we may have had a little explanation of your product, but I think we'd like to hear a little more about your company and what your mission is.
Sure, sounds good. So hi everyone, I'm Darren Kimura with Zadida. First question I always get asked is, what does Zadida mean? So I'll tell you right now, it's Moroccan for innovation and new. And that's really what we're trying to do at Zadida. We're a software provider. We have two primary technologies that we focus on. The first is an open source operating system which sits on edge devices in the factory floor, in the process automation systems, in the windmills, in the solar farms, wherever you need compute, that's where our operating system can live. And again, it's in the open source. The second technology we have is a cloud-based orchestrator, which is used to basically control, manage, monitor each of those nodes, we call them nodes, the edge compute systems that are out in the field. And also we have a marketplace which extends the power and capability of the applications that may be running in, for example, AWS or Azure. We allow you to bring that all the way down to the local compute so you can do exactly what you would do otherwise in the cloud, but on the local server in the factory floor.
Okay, thank you. And Tom, maybe you could, people are probably not as familiar with Kyndryl in this space, so if you could explain a little bit about Kyndryl and maybe why Kyndryl is relevant to a program on edge computing.
Yeah, thanks, Harry. I appreciate it. So hi, I'm Tom Henwood. I am a client technical leader out at Kyndryl. So a lot of you probably are not familiar with the name Kyndryl, and don't be ashamed. We've been around for decades. However, we used to be called IBM Global Technology Services, and we spun off last November. So we're a 90,000 employee infrastructure managed services company. We handle everything from private wireless network connecting IoT devices and large outdoor areas, whether it's a well field, whether it's a steel mill, manufacturing facilities, those types of things where it's hard to connect workers, it's hard to connect assets in harsh or very large environments. We do that work. We also do edge computing, IT, OT integration work, as well as cloud modernization, security, desktop services, kind of the gamut of the application stack.
Okay, thank you. And Ben, I'll give you a shot too. If you had to explain Phoenix Contact and your role in a nutshell, would you do that, please?
Oh, yeah. Well, so, yeah, Phoenix Contact, I think many of you know who we are. A lot of times people, they hear our name and the first thing that comes, little green terminal blocks in the back of all the devices or terminal blocks. We're a 100-year-old company here coming up. But we do much more than that. Like my role specifically within Phoenix Contact is within the vertical market space, specifically electric power, T&D. So we find a lot of our products can fit the gap where, you know, we're not the sensor, we're not maybe the SCADA and all that, but, you know, we can be the devices that will interconnect all those systems. And I mean, it could be from down to the wire, all the way out to the network switch, out to remote IO. So we find our systems being more and more used to allow you to interact or get the data from those end devices that are being increasingly deployed. And especially in the utility space, in our world, it's a little bit more interesting because, you know, we're dealing with a regulated environment versus, you know, going to a factory floor or a private enterprise where you don't have the same rules and requirements. So how do you take those technologies and deploy them in a very reliable and resilient manner so that, you know, you're not affecting your customer's process? And so that's really where our team tends to work in that area.
Okay, thank you. I'd have to say Derek's presentation brought me back a little bit to remember, and you showed that enunciator panel, and it brought me back to a plant that I used to work in that had something like 1,200 enunciator windows, and very many of them said, "This equipment, trouble." And that was the way, and so the methodology was send the operator. So I think having more windows isn't necessarily going to solve the problem, but no matter how many you get, you do tend to find them aggregated and kind of dead-ended like that. So it's a real situation, really, regardless of the size or the scope of the plant. This plant I was working in was a billion-dollar plant, but still had that kind of issue.
Yeah, like we just did the enunciator on just one unit, and when I showed you the alarm templates, I ended up making probably over 80 of them just for that unit, just to show basically just the systems and all the devices under it. But just for that one unit, there's like probably 360 end devices or alarm points for that unit. So when you think about that in the big picture, when you have an operator trying to, you know, look through 360 alarm points, it's like, yeah, that's a problem.
Yeah, it is. Okay, I'm happy to open it up to questions from the floor now. I have a couple of my own in mind, but if someone has a question they'd like to ask, just please raise your hand and we'll bring a mic to you. If not, I'm going to just keep going because I wanted to ask Philippe about, you mentioned you had 3 classes of applications there. I should have the slide in front of me now, but you had marketplace applications, and could you explain a little bit more about what that means? Because I didn't catch that.
The marketplace is basically we have Michelin. So I work for the technology center, right? SLIC. And we have this unit called Agora, which is our business. They work with the clients to get the requirements and then build the solutions that are going to solve their problems. And also with partners to develop custom solutions. And what happens is the marketplace is basically this selection of different applications for solving specific problems, right? So that it's like a catalog of solutions that you could use and deploy to our gateways.
Okay, so is that a Schlumberger?
Agora is Schlumberger. Yes.
Okay.
Yeah.
So it's a family of applications you can run there for different parts of Schlumberger.
Yeah, and we have partners as well that they have that work with us that develop solutions to put in our system as well. Okay.
Other questions? I'm going to open it up. I don't want to dominate here. Don't see any. Okay. Was there one? Oh, go ahead, please. Oh, we have a.
Hi.
There we go.
Question to Felipe. I thank you very much for a presentation. Thank you very much for all presentation, right? Very, very good. But my question for Felipe, it's about I saw that you use it like in the visual analytics, right? Some kind of maybe a object detection use case, right? That you recognize some of the security equipment or recognize some of the digits of some analog gauge, right? My question is about it's if it's machine learning model that you use there, how much accuracy you got from your cases, right? And the other question is about if you, for example, in your an analog gauge, you have an error, right? So like, say example, you say it's showing 9, but you say for any reason your model say 7, right?
Yeah.
What kind of solution you do for something like this?
No, that's a good question. So it's yeah. So I don't remember exactly what is the number, but it was pretty high, the accuracy. So the good thing is that in that particular case, it's in a controlled environment, so it's not in a place. It's not out in the desert, right? So it's a bit easier to control. And the solution as a fallback for what you're saying is, in addition to a digit, so we read the gauge and then digitize, right, transforms it in a number and push that up. It also takes the snapshot and then transfer that to the remote server as well. So if there is something that it is not well calibrated, someone noticed, oh, there's some issue here, you still can go and match to see what was the particular error. Right.
Okay, another question? Not seeing one, I'm going to ask another. Excuse me, I can't stop myself. But Herman, you mentioned AI being an important component in automation, and I'd kind of like to ask the supplier panelists to maybe address that a little bit more depth from your perspective. I'd like to know kind of what industries and applications you think are that you are seeing more in your business, and maybe are there specific applications, industries that you think are starting to grow within your own business?
Over the last years, we have learned what the capability of artificial intelligence is. Most of the architectures collect data on shop floor in the processes and make the calculations in cloud infrastructure and the way back. And we have learned that there are also processes which need real-time efficiency and real-time feedback. And so this was the idea to develop a hybrid concept where the real-time AI functionalities can be deployed on-site within the control system, and all others can be connected to a cloud architecture where enterprise calculations are going on, or factory calculations, but on a machinery, on a process island. Sometimes we have seen that there is a real-time reaction, very important, and there is not even one machinery what we deliver which doesn't have soft sensors. Soft sensor is really a very efficient method to improve the stability of the machinery, of the equipment, because you can substitute sensors in case of, and this is a method which makes no sense to transfer data into cloud and calculate and bring it back, because this is too cost efficient. And this was, at the end of the day, this was the start of our own development to rethink how can we reduce the complexity of the applications, of the AI applications, that typical automation engineers can use this functionality. And this was our answer to that we can now ship with every single machinery really very easy AI functionality within every system.
So machine control and analytics and skid-mounted systems,
Yeah.
we'd call them in the US skid-mounted systems. That's your answer?
As I said in the beginning, the situation we have been faced, that we have less data scientists which have the capabilities, or had the capabilities. And now with this move, we have the chance to deliver each and every machinery with these AI functionalities. And we have implemented the complete scope of machine learning notebook functionalities. These guys which are able to program in Python, they program in Python. And the automation guys love function blocks. And this is the approach what we did. We offer all our automation engineers a full set of functions that they can configure.
Okay, I will now turn to Darren. You have, in your view of projects or your universe of projects, how important is AI and where are you seeing it? And there's certainly many projects that I think you've executed where it's not relevant. So could you give us a perspective on that?
Yeah, I would say that just about, because we're in the infrastructure, we are used broadly across pretty much every single vertical you can think of that edge computing is operating in. And in our marketplace, our end users put the applications that they may develop proprietary or might be open. But I will say in almost absolutely every single vertical, AI is being used. So it's become the thing you have to have, I think, now as you're thinking about digital transformation or modernization. One example here at the show is one of our customers in the hallway is PeopleFlow. And they're using AI with the edge computing to be able to create a more efficient pumping system, which is able to measure against head and make calculations on a variable basis to adjust for pump motor, pump load, and things of that nature, but do that across the thousands of different pumps that might be, for example, in a refinery. And that's just one example. We see in the retail case a lot of video use cases, like Felipe mentioned, where in the past it was simply, still shots trying to identify things like license plate numbers, now going as far as trying to identify make and model and color even of vehicles that might be in a parking lot. So it's everywhere.
Okay. Tom?
Yeah, I'll add on to that. I think visual AI as well is really impacting manufacturing as far as defect detection. You may have visual AI running on a production line to identify if there's a defect in a product, if you're screwing a cap onto a particular bottle, has it been screwed on all the way? What's your level of confidence that it's been screwed on? And as these are going by very quickly, it can check product numbers. It can check if certain things have been seated correctly on a unit and alert when it's not, so that you can intervene. And when you use these types of technologies, you can really see an increase in the production flow that you can get through, a reduction in the number of defects and the false positives on defects that maybe someone would have stopped the production line for, or would have taken a unit off the line that was not really defective, but falsely alerted. So the newer, machine learning models that you can put together in the AI is really certainly allowing for some real improvements in manufacturing. And also, I would say using vision AI for safety. Is someone in an area that's hazardous? It can alert on those types of things as well, and you can really use it for health and safety of your workers.
Okay, Ben, do you have any comments on that? I would think you might be able to say, no, we don't use it at all, but I just wonder what you're going to say.
I was going to say, I'd say, the days of we used to joke that the utilities were a hub and spoke, right? Central generation, hey, you got 6 walls you're dealing with. Those days are far less, and it's more distributed. You said some of the talks where people are talking about distributed automation, distributed generation. There's a lot of sensors out there. You have to be able to detect faults in the lines, not at your plant anymore. Everything is being further and further spread out. So there's a lot of work being done right now. People are gathering all kinds of data. Can you do predictive, can you predict when a fault's going to happen based on certain scenarios you're seeing online? Can you, there's certain things you're not going to do. We always make the joke. Someone's like, oh, we can predict everything except the squirrel in the neighborhood 2 doors down from me who tends to climb into a transformer every other week. So no, I definitely see the utility space. You got to remember, these guys are covering more area. They're not getting more people. So they actually have to work. We say, work smarter, not harder. That comment is very true. So how can they, make their systems more efficient? How can they increase the line flow? Can you do dynamic line rating using all this data? Well, you got to have the algorithms that can make the adjustments in real time. The sense of California, it's already been talked about using, I know you guys are talking about vision systems, but the fires they had out there with wildfires, you can't just keep shutting power lines down every time you have high winds. How can you use systems that actually can monitor a line's movement using accelerometers? And maybe before that line hits the ground, using a lot of remote communication, 5G, talk about all these new systems we're deploying. How can you shut that line down with a protective relay before it hits the ground? all this requires an immense amount of data because you can't afford to be, oh, my bad, we just took that segment down and it was, not what we saw. So you have to be all the data has to be present and it has to give you the right information for you to make those type of decisions in that short period of time.
Okay, thank you. Give one more opportunity for the audience if there's a question remaining there. Not seeing one, I just want to thank these presenters and panelists for a great presentations and great comments on the session. So thank you all very much.